and welcome to Caldwell's and Associate case study. This case study is about an actual event. I don't use the customer name. I don't use the actual values, but I give you enough information where you can appreciate what the approach was and how difficult the problem was. So, what you see up on the screen is car body stamping, design of experiment. And that is a Lean Six Sigma tool, design of experiment, that allows you to cost effectively do experiment in production and also in labs, where you don't do experiments on a trial and error basis, systematically. And we have a case study that started in June. I worked on this in June and it was completed in November. So I'm just going to give you details, but not actual values. So this particular case study is a business critical problem solving, dealing with a new model launch on a SUV luxury stamping operation. The particular steel mill was supplying steel to the stamping for the complete car. But one of the stampings, the body side, was causing flakes, tiny zinc flakes. That's the problem. Because obviously a luxury car, you do not want tiny zinc flakes to get into your production and cause errors and problems in making the car or painting the car. So, and it slowed up their production rate. So that was a critical business problem. So all the other dies were working great, except this one particular one. And that's what made it unique. So let's look at the players. First we had the major automobile manufacturer. And let's say they were located in Charlotte, North Carolina. And then we had the stamping. There were stamping people there that, had the stamping, and in their opinion, the problem was the steel manufacturer, okay? And they were located in Macon, Georgia. So we got those individuals on the team too. And then you had a steel producer that had a plant in Dallas that was producing all the steel for the entire body of the car, of the SUV. Then you had the same steel producer had a plant in Canada, okay, Montreal, Canada. And they were also providing steel for the body side, because the body side that was coming from Dallas was creating tiny zinc flakes. So they still had to produce parts and product, get out the door, so they used the Canadian steel temporarily. But they wanted to solve it, so all of them would come from one steel mill and produce there. Here's the high-level approach that I took, all right? And first, I partnered with the steel mill, and I let them know that I would lead the design of experiment. I would do all the calculations for them. They didn't have to worry about that. But I would team up with their black belts and their subject experts. And then I needed to get an understanding of both plants' processes. So I took a visit to Canada, Montreal, and looked at their entire process, got data from their process, and also did the same thing at the Dallas, Texas plant. Then when I got to the stamping company, I told the stamping company that I would team up with their black belts, okay, and their subject matter expert, their engineers. And the reason why I did that is because those guys are the expert of what they do. I'm an expert, and Caldwell's Associates and people that work part of my team are expert at problem solving. First thing I did is understand their requirements and the things that they wanted, because that's important, the voice of the customer. And then we teamed up with, again, like I said, we teamed up with and let them know that we're going to lead the design of experiment. And then the last thing we did was we got with the automaker and just kind of eased their concern. Told them that it's going to take us a little time because we had to make new steel to meet our requirements, and we had to run this design of experiment, and they wanted to. So they agreed to do that. Everybody was in agreement, and everybody was open and honest and knew that that was the best way to run this. So here is just one of the equations that was used, and what this was a very important equation, and all it is multiple regression analysis. And the reason why we use this equation is because this equation allowed us to identify where critical data points that was causing the zinc flakes were. Okay, so I was able to use regression analysis to determine the critical variables that was driving the zinc plate. And I was able to do that based on their trial and error data that they had done prior to me coming on board. They had done some trial and error trials at the stamping, and with black belts being there, they collected the data correctly with pictures and all those, every little detail, which was great. So from there, we had the data that we need in order to set up the design of experiment. So here we set up a 2x2 factorial design of experiment. And what you see in this box is 4 boxes in a box. And what the 4 boxes actually show you is the different type of scenarios you're going to be running in your experiment. So box 1 shows the low value of roughness and the low value of peak count, because those two was our critical values that was causing this zinc flaking. And that's where we got it from, our multiple regression analysis equation. Then box 2 show you the high and low value. Box 3 show you the low and high value. And box 4 shows you the high and high value. So this is, again, a cost-effective way of finding out what should work and what shouldn't. Now, for this experiment, we should have 2 boxes should pass and 2 boxes should fail. Okay? Let me show you the results of the experiment. Here's the results of the experiment. What we found was box 4 passed with no zinc, because that was the criteria that the stamping company wanted. They wanted no zinc, which is understandable. And that's Six Sigma type of mentality. You want it perfect, near perfect, okay? And we had box 2 was marginal. It was light to medium zinc, okay? Marginal, I colored it yellow, but it actually failed because it was not 0. And then box 1 and 3, they both was heavy zinc, okay? So at that point, the stamping manufacturer wasn't sure what the next step was. The mill manufacturing, they wasn't sure. And the automobile company was not sure what the next step was. But what we did was we always look for the root cause. So I went back, analyzed the data from Montreal plant that were making good parts, and from the Texas plant that wasn't making good parts. I found that there was a statistical difference between the 2 plants' processes. Once I found that, I started looking at the operations that was driving this zinc and at what step of the operation could be causing this. So I set up the multi-regression analysis to determine what step in the operation, in the mill operation, was causing this. And what I found was, here is the outcome, that in the steel processing plant, step 17 was driving the zinc flake. In step 17, where it passed, it had a value of 5,036. And then where it was marginal, it had a value of 4,659. And then where it started falling at 4,299, and it got progressively worse. It was a linear reaction as the volume of the value of that operation went down, the more zinc we had. That's exactly what they needed to hear. We were able to determine the root cause and where they should run this particular operation so they would not get any more zinc problem. This was validated by their R&D lab. The steel manufacturer R&D lab set up a miniature stamping die and duplicated what we found mathematically. So with that shows you our approach. At Caldwell and Associate, we specialize in root cause problem solving. Critical business problem solving. When you have a critical business problem, whether it's quality, whether it's capacity, or any problem that's chronic or acute that you're having a hard time solving, give us a call. Because we don't know your product and your expertise. We give that to you. But we work with your experts and with our knowledge of determining and looking for the root cause brings a dynamic and incredible team. And we can help you. So I hope you enjoyed this case study as much as I did. I enjoyed it doing it and also presenting it. So with that, I'd like to say have a nice day and thank you for your time.